Good day once again. I'm Seneto, the mathematics engineering tutor. Thank you guys for watching my videos. So I'll keep on posting more videos for engineering mathematics. I'm also encouraging for the guys who did not subscribe yet to do the right thing. Keep on subscribing so that I can post more videos on this module. Also today we're still going to continue revising your assignment 2. So we are going to focus today we are going to focus with 2.3. 2.3 we are dealing with we need to determine the two square roots of the complex number. So today we are focusing with 2.3. So here what you must know how to find a square root. So I'll just start by demonstrating on how to find a square root. Which formula do we apply on how to, when you're looking for a square root? Sometimes they can ask you to find the cube root or the fourth root. So I'm going to show you the formula that we are going to use before you answer the question. So here today we are dealing with the roots. Okay. Yeah. It's a root of a complex number. Roots of a complex number. Yeah. So what is very important that you must know is that usually when you're looking for a root of a complex number, okay, yeah, I'm going to wrap here so that I'll create more space. Yeah, let's say you're given, if you're given z is equal to your r, yeah, you'll be yeah, okay, let's say you're given z r, then cos theta plus this j, which is imaginary, sine theta. Okay, as you can see, this formula here, you already know that this one is it's a polar form. It's the formula to find out your polar form. Then they say then the nth roots of z are given by the formula. Okay, then the nth, okay, let's say the nth roots of z, okay, let's say of z are given by the formula. So you must know this formula, guys. You need to know how to apply it. Let me use different color here. Yeah, it says wk is equal to, yeah, okay, there's a root here, there's the n here, let's say r. Okay, let's use this bracket here like this. Then here it will be cos, you can say here cos. Yeah, I think I'll just try to combine it. It will be cos theta plus, okay, it's cos theta plus 360, okay, 3, sorry about that, 360, then there's a k degrees, okay, k multiplied by k all over n, the plus imaginary, which is your sine, same applies this to what, theta, okay, theta plus yeah 360 degrees here, please, all over, and remember here there's a bracket. Yeah, my space is too small, but I hope you can see the formula, guys. This formula is already given in your study guide. If you check your study guide for mathematics, it's already there. So here I tried to squeeze it so that was my space too small. If you check your study guide, they separate it. Here they just, instead here they just write like, they just say theta over n plus 360 degrees k over. Yeah, if you check your study guide, it's like this. So it's the same thing. Because if you check here, I'm having my denominator is the same. It's n and n. So which means here it's more like theta plus 360 degrees multiplied by k over n. It's the same thing. So don't be confused about that. It's more like the same thing. So me, I just combined it. Okay, so this is your formula that you need to know how to apply when you are looking for a root. It can be a square root, a cube root, or maybe fourth root. It depends what is your question. So here I'm going to explain like what is the meaning of this formula. What is your n and what is what? Your k. Then your theta you already know. Okay, let's start with that n. That n, it represents it's your usual that n, it's a positive integer. For example, which has exactly that n, it will be a distinct root, which will be given like this one. For example, I can say here, just for example, that n here usually to be positive. I can give example. Let's say example, e.g., if they ask you find what, they're gonna say find the square root. For example, if it's a square root, what you know that your n will be equal to 2. You know square root, your n, that n will become 2. That is it. Just for example, I can say, and since here, from that, okay, I can say that I can use that radical formula, that is square root of r. So your if it's a square root, which means your n will become what? Your 2. So this is what it means, just for an example. So whenever they ask you for a square root, which means your n is equal to 2. That is the first thing that you must know. I think here it's clear. So I think in the other way, even if you don't write your 2 there, I think you know, guys, you already know. If you write like this, if you just square root of 2, you already know that here there's what? You already know that your n is 2. If there's no number, I think you know this is very important. So that's the thing that is very important. So whenever they're asking for a square root, your n is equal to 2. Then what is next thing? If they're asking for a square root again, you must know what is your k. That k, okay, if you check here, they're saying where k, let me say, where your k is equal to 0 or 1, 2, then they say dot, 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 then n minus 1. Yeah, which means your k is starting from 0, 1, 2. So for this question, let's say for this example that I'm giving, let's say they're asking for a square root, which means your k, you pick your first 2 numbers. Since our n is 2, which means you must have 2 terms for our k. So which means if it's a square root, okay, therefore for this scenario here, our k here, our k will be equal to 0 and 1. That is the thing. We are done. So which means our square root, we need to find where k is equals to 0, then where k is equals to 1. But anyway, guys, no need to worry. We are going to do an example on how to apply this formula. Then I'll be doing step by step applying this same formula. So for this scenario here, I'm just giving an example. Let's say if they ask you for a square root, you must know that your n is equals to 2. Then your k is equals to 0 and k is equal to 1. So that is it. Then the next thing, another example. Okay, I you know your theta, your theta, that theta which is given, it's your angle, which is your, I can say your theta obviously is it's your argument. Yeah, that is the angle from the x-axis. So you just need to calculate. You need to have it. If you don't have it, you must calculate. Then your R, you know your R, you already know that your R is what? It's your modulus. You know how to calculate your modulus. Okay, it's fine like that. So let's move on another example. Let's say if they say find the cube root. They can say find what? E.g., let's find what? The cube root. If it's a cube root, which means our n there, our n will become what? Our n will become 3. That is the thing, guys. So which means from here, you are going to say cube root of what? Of r. You place your 3. That is the thing. Just simple like that. So your n is equals to 3. So if your n is equals to, which means you need to find the cube root of r, which is the cube root of your modulus. Now, what about your k? How do you find, okay, how do you deal with that k? Which means your k here, since my n is 3. So what you must know here, you are going to say, I'm going to have first 3 terms of my k. Since our k is starting from 0, 1, 2, so which means my k here will be equal to 0, 1, and 2. So we need to find whereby k is equal to 0. Then look whereby k is equal to 1. Then lastly, you look whereby k is equal to 3. So that is the thing when you are dealing with the cube root. I hope guys it's making sense. So this is how you do. This is how you apply this formula. So maybe the lastly, but usually they will be asking you for square root of cube root. But okay, let's do lastly. Let's say it's a fourth root. But usually they don't ask for this one. I'm just giving an example. If it's fourth root, which means the n is equals to 4. Therefore, here from this formula here, what I'm going to do is going to be this. Your here is going to be a 4. It's a fourth root. Okay, just an example. So fourth root of your r, which is fourth root of your modulus. So what is going to be your k? My k, which means if n is equals to 4, I'm going to have first 4 terms. Yeah. So which means your k here is going to be like this. Let's just do it. Okay, your k. So which means your k is equals to 0, 1, 2, 3, and what? And 4. So you need to find out whereby k is equals to 0, then find out whereby k is equals to 1, whereby k is equals to 2, whereby k is equals to 3, then lastly whereby k is equals to 4. So that is, guys, about when you're dealing with this what? With the roots of a complex number. I hope guys it's clear. So just pay attention now as we are going to do an example on how to apply this formula. So from your assignment, I'm going to focus with the assignment, but as I said previously, I'll play around with the numbers. I'm not going to do the question as it is. I will just change the numbers from your from your assignment. So what I'm going to do here is that, yeah, for 2.3, let's go to 2.3 now. They are saying determine the 2 square root of complex number. So we need to find the square root of this complex number. It's given -3. So here I can say negative, okay, -2 minus j. Okay, let's say negative. I can use negative. Yeah, which one can I use here? Maybe I can use -3 here. Yeah, I think it's going to be fine because since I said, yeah, guys, I just applied different what? Get different numbers here. I just play around with the numbers. Okay, so let's say here this is your question. You are going to focus with this one. We need to determine here. We need to determine. Yeah, let's determine what our 2 what? Square. Our 2 square root of the complex, and our answer must be in what? In polar form. So that's the that is very important here. So here is our example, guys. Let's solve for this example. It's very important. So here what you must know, guys, you need to know how to, you must know the steps on how to find what our square root by using the formula which is given there. That formula that I gave you guys is very important. So you need to know how to apply the formula first. Yeah, your formula is very important. So okay, I just need to write down this. Okay, this example. I said our example, we need to find the root of what? Of negative 2 minus imaginary number of negative 3. So guys, before I solve here, as you can see from the formula that I showed you guys, for that, can you see that your formula, it was saying if z, the formula was saying if what? If z is equal to r cos theta plus j sin theta. Can you see from our formula? This one, as I said, this one is what? It's a polar form. So which means, guys, for us to find the square root of this, here we're given is what? Which is given there, it's a rectangular what? This one is a rectangular form. It's not in a polar form. So what our first step that we need to do is that we need to convert this rectangular form to what? To a polar form first. That is our first step. Yeah. Since the given question is not in polar form, so we need to convert it to a polar form from the rectangular form. So let's do it. I hope guys will remember to do this. To convert from a rectangular form to polar form. And let's do it. If we don't know, let me try to show you. I'll do it step by step, as it is very important to convert that. So let's do it. So I'm given negative 2. This is my example. Negative 2 and minus imaginary number of what? Of 3. So I want to convert it to what? To a polar form, which is r cos theta plus j sin theta. So the first thing that you need to know, you need to find our r, which is our modulus. You know that r, we find it, r is equals to square root of what? Of negative, you can say negative 2 squared. You can say negative 2, it's fine. Or positive, there's a square already here. Plus. So what you get for r here? It's square root of what? Of 4 plus 9, which is your r, it's what? It's square root of 13. So you can leave our answer like this. That is fine. Our r here, it's what? It's square root of 13. This one will become our modulus. So we are covered for r. Now what is left? We need to find our theta. That theta is going to be our argument. So guys, which is very important that I'm going to show you today is that when you are looking for your argument, guys, I'm encouraging you guys to draw what? The argand. There's what you call an argand diagram, because you must know where your r, or where your argand diagram is. What is it? In first quadrant? Is it in second quadrant, third, or fourth? So that you can be able to calculate your argument perfectly. So let's do it. Let's draw our argand diagram first. Since we're having our r is covered, let's do the argand diagram of this complex number here. As you know, we'll be having x and y and it's what? It's y-axis and x-axis. So what you must know is that your x-axis, this is where you find your real numbers. So I'll leave it like this here. Your real numbers are on the x-axis. Then your y-axis, this is where you find your imaginary. Yeah, this is where you find your imaginary numbers. So this thing is very important. You must know it, please. Yeah. So let's move on. Yeah, then here it's 0 there. So I can say 1, 2, 3. So minus 1, minus 2, minus 3, 1, 2, 3 this side, minus 1, minus 2, and minus 3. Now let's check from the given rectangular form there, which is minus 2, minus 6 is your real number, then the minus 3 is your imaginary number. So let's find out which quadrant is that. Is it in first quadrant? Is it in second quadrant? Is it in third, or it's in fourth quadrant? Let's check now. Yeah, we're having minus 2. Minus 2 is your real number. So where's your minus 2? It's here. I'll mark here. That is your minus 2. Then where's the minus 3? Imaginary number. Imaginary number, where's minus 3? It's here. So which means where they meet here. Yeah, at this point, which means I'm going to draw my arrow here. Let me draw it. It's this one here. Now this is what you call an Argand diagram. So which means, as you can see, this the diagram, our Argand diagram, it's on the what? It's on the third quadrant. That's the thing which is very important. So you guys will already know how to find our theta or argument. So the general formula to find it says, the general formula, it says what? Let me write down the formula. It says tan what? Tan inverse. Tan inverse of what? Tan inverse of what? Of b over a. My b here, okay, it's tan inverse of what? Of imaginary over a real number. So tan inverse, what is your your imaginary? It's minus 3 over your real number, it's minus 2. So guys, I think just use your calculator. So it's like tan inverse of 3 over 2. So if you use your calculator, second function tan 3 over 2, you're going to see your answer that are good. It's 56. Yeah, let's say it's what here. Let me see here. So here, our angle here, it's 56,3. Okay, let's leave it 1 decimal place. It's fine. Yeah, 56,3. So guys, I want to ask you something. What does it mean? Which means here, guys, this angle that you get, it's from this here. Like, let me label it here. It's from this line here. I think this one we call it x-axis. Yeah, it's from that is your 56, what? 3. So let me label it. It's 56, 3 degrees. So, but what you must know, whenever you're looking for your argument must start from the first quadrant. I think guys, you must know that. You must start from here up to your line here to your Argand diagram. So this is the angle that you are looking for here. So how to find your angle from that first quadrant up to this given Argand diagram there? Which means you already know that here, this one we're having a straight line first here. So you know that here it's 180 degrees. Here it's 180. Yeah, you're on the y-axis. I think you know that here it's 90 what? 90 degrees. On the first quadrant, you know that here it's 0 degrees. So now guys, how to find our argument angle now from the first quadrant, which is from that first quadrant? Which means what I'm going to do, I'm going to say this 180 degrees plus this 56,3 degrees. I hope guys you did get this. So this is how you find out your argument. This one is going to be your argument of your what? The argument of the given complex number. I hope guys it's very clear. But I'm kindly asking you guys, if you're not getting this, try to repeat the video. Try to rewind the video so that you can understand it, because this thing is very important. So as you can see, our argument is not 56,3 degrees. So if you use 56,3 degrees, which means you are wrong, because 56,3 degrees is the angle from that x-axis. As you can see, our Argand diagram is in third quadrant. So we add with what? With plus 180 degrees. So we're going to say 180 degrees plus 56,3. So that is it. So which means my argument for this one here, if we add, I hope guys are also using calculators. So let's do it. I'm going to rub this since we are done with this one, which means I'm going to say my theta here, my argument now, it's 56,3 degrees plus 180 degrees. So this one will become your argument. It's 236,3 degrees. So you just need to write it down, guys. So we are done now. We are now having the modulus and what? We are now having our modulus and our argument. So let's write down, since we are looking for the polar form. So our polar form, since the formula is saying r cos, okay, I mean r cos theta plus j sine theta. Yeah, your r here, it's what? Your r, we said it's square root of what? Of 13 bracket cos. My theta, which is my argument, is 236,3 degrees plus j sine 236,3 degrees. Now this one will become your polar form. Now we need to convert now, guys. What you are looking for, we need to convert. I mean, we need to find the 2 square roots of this polar form. Since for us to find the roots, guys, we must have the polar form first. According from the what? From the formula, we must have what? Our polar form. So that is it, guys. I hope you are getting this. Okay, so what is next from here? Let's go back to our formula now. We are looking for the what? What we are looking for? We are looking for the square root. So what is your formula first? Here, what I'm going to do here, let me write the formula again here. So which means I said our formula is say wk is equal to okay, it's square root of n here, r. Okay, you can put a bracket. It's going to be cos theta plus 360 degrees. Okay, 360 degrees k over n plus j. It's sine. Okay, okay, theta plus 360 degrees. Okay, let me hash 363k here. Yeah, I'll put a bracket here, guys, please. All over n. Yeah, as you can see, this is your formula, guys. Yeah, and now we need to understand now what is your n first. So since we are looking for a square root, our n here is what? Our n, as I said, our n we are covered is what? Is 2. Yeah, we are done. Then our r, we already have our r, guys. Our r is what? Remember that your r is square root of what? 13, guys. Please don't forget that. But if you check from the formula, there's already a square root there. So you must mind that. You must be careful about that. Yeah, it's very important. Then next, which means our k here is going to be k is equals to 0 and k is equals to 1. So which means we are going to have two conditions here. Our first root is going to be what? Where k is equals to 0. Then our second one, where k is equals to 1. That is it. We are done. So I'm trying to give you a hint, yeah, about of this. So guys, I'm kindly asking you to copy the question, then write the formula. Then after that, just write everything that I did here, so that I can rub my board. I'm going to rub so that we can continue now. So where I'm going to start from here, I'll be starting from the formula first. Yeah, so on the next step here, I'm going to write the formula only. I will assume that you already copied your polar form. Please copy that polar form which is here. Your polar form, which is this one there. We said this one is your polar form. As you can see, the formula needs a polar form. You must have a polar form, which is very important. Then your theta. Okay, our theta, as you given a theta, our theta is our argument, which means our theta is 236,3 degrees. That is your theta there. I think I'm no longer having space here, but you must know that your theta is what? Is 236,3 degrees. And as I said, is 2. Since we are looking for square root, Our k must be k is equals to 0 and k is equals to 1. Then our r, it's given, it's square root of 13, which is what? Our modulus. Okay, so that is it. So from here, what I'm going to do here, let's proceed now. Let's move on to what? Let's move on with the calculation. I will rewrite the formula again. Okay, wk, okay, is equals to square root of r, then n here. Yeah, open the bracket, cos, okay, theta plus 360k. Okay, I mean 3. Okay, sorry about that. 360k over n, the plus j sign here, theta plus 3. Yes, 360 case. There's a degree over n. Yeah, that is your formula. So let's move on. So since I said our n is what? Our n is 2. Then our r is, we said our r is square root of 13. Yeah. So then our n is 2. So let's substitute to our formula here. So which means it's going to be like this. So let's start with what? Let's start with the k. We're going to start with where k is equals to 0. That is our first condition. So we're going to say equal to, or okay, so some they just say w, yeah, w 0. Since our k here it's so which means we can say w 0. Since our k here it's what? It's 0. So let me use different color. Is equal to, yeah. Now let's move on. Our r is square root of 13. So guys, mind there is going to be square root of what? Of 13. Yeah, this is our r already here. It's and on the formula there's what? As you can see, there's a square root. So it's like, it will be like this: square root and square root of 13. I hope guys you did understand what is happening here. Yeah, please, because remember from your r here, this one is from the original formula. Our r it's already our r is already having a radical. It's already having a square root of 13, of which the formula is also having what? A square root. So which means you are going to have 2 square roots like this. So I hope guys you know what does it mean like if it's like this, but we are going to I'm going to explain it. The next we'll go to opening our opening bracket here. So we say cos, what is our theta? Our theta, which is our argument that we get from that polar form. Our theta there we said is what? 236. So we said 236 comma 3 degrees, that plus 360 degrees. Yeah, remember guys here, your k, we said our k to start with k is equals to 0. So k is 0 all over. Then I'm following guys here, I'm following the formula. So what is your n? Your n is what? Is 2. Yeah, just simple like this. The next we go to what? Since there's no, yeah, say plus, I'm going to my imaginary now. My imaginary is what? I sine, okay, I mean j, imaginary, which is sine. Your theta, which is the argument that you get from that polar form, 236,3 degrees plus 360 multiplied by 0 all over, yeah, this thing here. Yeah, remember guys here, please don't forget that over here, it does not affect. Don't forget that here. That's why sometimes they put a bracket here. Don't, please, yeah, we need to simplify it separately, like here. So which means some place here, we need to simplify it separately. So all over 2. Now you can just use your calculator guys from here. Yeah, so this one is very, let me use it now, a closing bracket here over the second, a closing bracket. So yeah, I think if you use a calculator, let's simplify. Yeah, what is going to be, let's start with this one here. You can use, yeah, I think here from this step you understand, guys, what does it mean. If it says square root, then square root of 13, you know the meaning of this, guys. So without wasting time, let me just wrap only the top part. I assume the guys are done copying here and this formula, so that we just focus on this part. Yeah, we are focusing here now. So let me start with equal sign. If they say square root, then the square root of 13, you know that this thing, guys, it means, it's obvious. I think it's like this, guys. I think, guys, you understand me. If I write like this, it will be like this. Then here it's going to be 4. I hope, guys, you understand. Like from this step here, it's like this. That is the, or okay, let me explain it further why I'm saying so. Because obviously I'm having two what? 2 square root. So which means it's like I'm having 13 bracket to the power of half, and another one is 2 times what? To the power of half. Since I'm having 2 square roots, so which means my exponent, if I convert it to an exponent, it's going to be 13 to the power of what? 1 over 2 multiplied by 1 over 2, which is what? 13 exponent 1 over 4, which is equivalent to like this here. So that is it. So you just need to know, guys, it's very important in this one. So I just to explain it where I'm getting that that n, yeah, that 4 exactly. So which means here is equal to but see, I need to create more space here because okay, it's going to be like this here. So which means here it's 4. I think you just use a calculator to find out your actual number there. Now let's move on. Yeah, opening bracket. So what is going to be your cos here? You can just use a calculator, guys. Say 263 comma 3 degrees plus 36 times 0. It will be 0 here. So just divide by 2. So we are going to get 131,65. 131,65 degrees. Then plus, so which means even your imaginary, it will be the same answer. If you use a calculator to get 131,65, then closing bracket. Now this one will become our, it's going to be our polar. These are our polar form. I think you can just simplify it now. Just find what is this, what do you get here? If you use a calculator there, that one, it's like a 4th root of what? Of 13. Yeah, it's like a 4th root of, you can use a calculator. That you can find your answer. Oh, I'm fine. Okay. Oh, sorry about that. Yeah, okay. Let's check here. So if you get this one, if you find the 4th root, I mean the 4th root of 13, what you get is 1,89, but I can round off here. I think if round off here 1 2 to 1 decimal places, it will be, let's say 1,9. It's fine. Then opening bracket, it's cos 131,65 degrees plus j sine 131,65 degrees. So guys, I think this one will become your polar. This is your final answer for this one, whereby k is equals to what? So that is your first answer here. Since the question is saying we must leave our answer in what? In polar form. So you can leave your answer like this. It's fine. Now, which one is your second answer? Since we must have 2 answers, guys. This one, it was whereby k is equals to 0. So our next answer is going to be what? Our next root is going to be whereby k is equal to 1. So you just apply the same procedure, guys. You apply the same formula. Then you find what? Your second root. Let's just do it since our time is moving. What I'll do here, I'll rewrite the formula again because guys, there's no way. We just need to use our formula here. There's no option. So our KWK, I mean WK, then square root of R here, N here, okay. Then it's going to be, okay, cos theta plus 3 60 degrees K over N plus J sine theta plus 3 60 degrees K over N. Yeah, so yeah, since we are looking for the second one, which means our N is still N is still 2. Then about our K is now what? 1. Then we said our imaginary number, I mean our argument 236. Just using that 2 what? 36,3 degrees. Yeah. Then what is next? I think it's fine now. Then our R, we said our R is root of what? Root of 13. So let's do it. So we are now, let me use different color. It's W1 here. So here is to what? It's square root of 13. Okay. Now next, it will be cos. Yeah, cos what? Your theta was 2 what? 36,3 degrees plus 360 degrees multiplied by 1 here all over your N, which is your 2. Yeah, then plus I, okay, J, it's J here, sine your theta, which is 2, 36,3 degrees plus 360 degrees here times 1 over 2. Please mind you can put a bracket here, please guys. Yeah, so that it will show that it's yeah, you must do it separately. So that is it. We are done from there. Now we can just use a calculator now to find what this second root. Yeah, so I think I can wrap the top part here so that we just focus with this part. So what I'm going to get here, since I said square root of 13, we already calculate this one. It's like it's cube root of what? I mean, it's fourth root of what? We said it's fourth root of 13. We get it's 1,9. We said it's 1,9, so it's 1,9. Then opening bracket here. Sorry. So cos. Yeah, I'm now okay. I'm now. I think let me use different color here because of it, so that it will not confuse here. It's 1,9. Yeah, equal to 1,9. Okay, then we say cos. Yeah, now let's use the calculator now. Let's use the calculator. What is 236? 236,3 plus 360 divided by what? Divided by 2. So what you get is 298. 298,5 degrees plus J. Over the answer will be the same also. You also get J sine 298, I mean it's 15. Now this one will become your, yeah, I'm sure this one will become your polar form. This is your second root. So guys, that is how you calculate this question. This is the procedure that you can use to what? To do this question. I hope guys you did understand. I'm also kindly asking for your favor, guys. Keep on subscribing my channel so that I can post more videos. I'm going to do more topics under this module. Thank you.